Hello, this is Dr. Joseph Stewart with the History of Science and Medicine class. Our lecture today is called Achievements of Medieval Science in Europe. Let's begin with prayer. Grant me grace, O merciful God, to desire ardently all that is pleasing to Thee, to examine it prudently, to acknowledge it truthfully, and to accomplish it perfectly, for the praise and glory of Thy name. Amen. Welcome to the Middle Ages. In this image, a sketch by Rembrandt from the 17th century, he's picturing here an old medieval windmill, and usually used for grinding grain. These technological achievements were particularly prominent in Holland, where there's not a lot of fast-moving water for water wheels because it's a very flat country. So you have a lot of windmills developed in Holland, and this horizontal axis windmill is one of the great technological feats of medieval Europe, essentially invented by medieval Europe. And this is the ancestor to modern turbine technology that is being used in renewable power in the modern world. This is where the adventure all began. Now, this works against the bias of the Middle Ages that a lot of people still have, even today, particularly certain popular historians and journalists and people in the media speak about the Middle Ages as a kind of dark age, that the progress of civilization happened by sort of like leaving religion behind and escaping from the chains of the church, and then we finally get science breaking free with Galileo and Newton. And that story, as we've already commented, I think in this course, is untrue. And many, many historians have been sort of uncovering the biases that are inherent within that view of history, which kind of arose really in the 1800s and spread in the 1900s. Well, this idea that there's a warfare between science and religion is simply bad history. Around 1900, historians began to realize that that narrative was wrong as they began discovering medieval manuscripts with scientific discoveries and treatises in them, and realizing that there was a lot of sophistication behind medieval science and that it actually helped to lay the foundation for the scientific revolution itself in the 1600s. So, come to find out, historians have affirmed in many cases that the church never supported the idea that the earth is flat. Very few people believed that in the Middle Ages. Even back to the ancient world, there were plenty of people that believed that the world was round. The church never banned human dissection. In fact, it was a sponsor of it. The church never banned the idea of zero and never burnt anyone at the stake for scientific ideas. So, with clearing away some of those myths, historians have also realized that there's some pretty fascinating examples of discoveries coming from the Middle Ages. Spectacles, for example, the mechanical clock. We'll talk about that in a little while. The blast furnace, the horizontal axis windmill that I already mentioned. And in addition, medieval peoples advanced technology that they didn't invent, but it was derived from somewhere else, but they then built on that and made it better, such as the compass, paper milling, printing, stirrups, and gunpowder use. And that these improvements in the Middle Ages laid the basis for Western civilization coming, for good and for ill really, to dominate much of the rest of the world after 1500. Yeah, so that's sort of the background, the big picture that I want to present today. And a good place to start is the University of Oxford, which was established around 1096 or so in the kind of the central Middle Ages as one of the great institutions of learning in the world, and still is, of course, to this day. And medieval Oxford had many different subjects to study, but some of them involved physical sciences and mathematics. Here's a reconstruction drawing at the top of this slide of what medieval Oxford may have looked like, and a picture here of 14th century picture of Robert Grosseteste, who was Chancellor of the University of Oxford, and later he was Bishop of Lincoln. He was also a natural philosopher, which is the phrase we use for scientists in the Middle Ages, a natural philosopher. So more about Grosseteste in just a minute, but first just a little background for the medieval thinkers. For them, the world is infused with reason and goodness. We've already talked about this, back to Genesis. Man made it in the image of God, the world is good. Humans name creation. That's what Adam did, and that signifies this kind of correspondence between human reason and the world as God has made it. Greek thought was often true and good and absorbed into the medieval Christian intellectual milieu. Greek thought was compatible with the Christian worldview. We've seen that back into the early church in previous lectures, and we see it even to a heightened degree here in the medieval period. Reason and faith are both distinct, but never really in conflict. This ultimately freed natural philosophy to get on with the study of nature without being tempted to indulge in sort of illicit metaphysical speculation or theology. In other words, distinguishing between faith and reason allowed reason to be true to itself and not try to pretend, to come up with truths of faith. So that was an important point because it allowed reason freedom to actually engage with the natural world on its own terms. That's the naturalism that we've traced from the Greek world, and then we've seen embraced in the Christian world, and Christian theology actually created a hospitable place for that naturalism to reside. Now, Robert Grosseteste, pictured here, was born around 1170 and lived until 1253, right in the heart of the Middle Ages. He was an English statesman, scholastic philosopher, theologian, scientist, head of Oxford, and also a bishop. He was born of humble parents in Suffolk, and one historian of science calls him, quote, the real founder of the tradition of scientific thought in medieval Oxford. Fascinating. And in some ways, he was the founder of the modern English intellectual tradition as a whole, which really prioritizes empiricism, knowledge through the senses. Now, in the early 1200s, he was writing quite a bit on astronomy, light, the tides, and rainbows. In optics, this convinced him that light could be represented by lines. Therefore, geometry and math are the highest sciences and the basis for all the others. So the Greeks, too, in some ways connected mathematics to the study of the physical world. We see this theme in the Middle Ages. We'll really see it with Galileo and Descartes in the scientific revolution. But this, Grosseteste, this man here, is an important prefigurement of that development in the 1600s with the scientific revolution. And now the churchmen of the time were quite fascinated by light, especially Franciscans. So God's first words were, "Let there be light," as a fundamental property of the universe. They thought of light as both physical and spiritual, letting us see certain spiritual truths and understand the mind of God to some degree. So there was a really fascination with the study of light and optics by medieval natural philosophers. And that was true amongst Islamic thinkers as well, actually. Now, Grosseteste appealed to experimentum, or experience, through observation, as we saw in Aristotle, right? So we don't quite yet have systematic controlled experimentation that we'll get in the scientific revolution. We have some of that going on before that, but mainly what we have in the natural philosophers is to observe nature in its natural state, because otherwise you don't want to sort of mess with nature in an artificial kind of experimental situation, because you want to observe nature in its natural state, and you don't want to interfere with it. So this is the idea of knowledge through observing nature. And we'll have to wait until the scientific revolution to really get a fully developed idea of controlled experimentation. But we'll get there, and this appeal to experimentum, or experience through observation, in the medieval period is an important link between the ancient world and the scientific revolution, here right in the heart of the Middle Ages. So, Grosseteste, his achievements, and others at Oxford really established an important scientific tradition in the Middle Ages that carried forward to places like Padua in Italy and on to figures like Galilei in the 17th century, is really an important background to the scientific revolution. Now, here's another figure that's connected to the University of Oxford in the medieval period, Richard of Wallingford, 1292 to 1336. And he was born just south of Oxford, a little town, Wallingford, and he was the son, a humble man, a son of a blacksmith. So he was used to not just work, but very challenging physical work in the molding of metal. And this would be super useful to his own work, as we'll see, in creation of a highly sophisticated mechanical clock, really for the first time. So he had a keen interest in the mechanical arts and respect for craftsmanship. And this introduces a really interesting theme in the history of science, which is that to have scientific progress, you have to have both theory and sort of high understanding of natural laws and mathematics and things, but you also have practicality to create the kinds of experiments you need and the kinds of instruments you need in experimentation, right? So you need both practicality and theory. And those two would really come together. Somebody like Galileo really linked that world of craftsmanship, like with the use of the telescope. We'll get there. To the world of theory. And much of the problem before the time of Galileo was actually a separation. You have sort of, white-collar professors who don't want to get dirty, and then you have people who do get dirty and make things. And they were two separate people usually, back into the ancient world and somewhat into the Middle Ages too. Although you get certain people like Benedictine monks, for example, who both work and pray and study, who have that practical side and that theoretical side. And so you start to get overcoming some of that barrier between the professorial elites and the people who know how to do things. And it's only when you bring those two things together that you begin to make scientific progress. And we see this in Wallingford to some degree, because being son of a blacksmith, he also then was taken in by a local Benedictine monk and educated. And then he would head off to Oxford nearby as a student, where he learned, as all the other students, to speak in Latin. That was the universal language, so you could be from anywhere and have a common language. In fact, you could actually get fined for not speaking in Latin at Oxford. But anyway, he eventually joined the Benedictines, which allowed him to continue his studies at the University of Oxford, which was pretty common. If people wanted to study, they often became a monk or a priest. And in 1314, he earned a Master of Arts degree. And so he connected this rational training within the university and this tradition of natural philosophy established by Robert Grosseteste and others. He linked that to the practical training he had had as a young boy as a blacksmith. And so this was pretty fascinating, because this was an example of the University of Oxford serving as an avenue of social mobility. Here's a humble guy, blue-collar kid, who rises up through the university to become an abbot of a monastery and a great inventor and scientist. So this is fascinating in the medieval period of this rise from between different classes. But anyway, he used money from the monastery, where he was the abbot, to help build the most advanced mechanical clock ever seen that would keep track of both time of day, but also position of sun, moon, and stars. And unfortunately, that clock was lost or destroyed during the Age of Reformation in the 1500s with King Henry VIII. However, based on his notes, there have been people who have tried to reconstruct the clock, and it looks something like this. You can see the ropes down going beneath the floor. That's where the weight is. The weight is supplying the power that's driving this thing. Now you can see swinging here, it's called the escapement, back and forth, which is connected to the gear down below, and that sort of checks the Let me just jump back, actually. So this gear is connected to the escapement, which is flinging back and forth at the top there, and connected down to the gear, which keeps it from moving more than one notch at a time. And this was the secret to mechanical timekeeping, was the creation of this escapement. Good. So the idea was that the universe is like a clock, and that the world is like a machine, and that we can understand it in terms of different forces. This is an idea associated very much with the scientific revolution, but what we see is that the idea of the world as a machine was actually born in the medieval period. And the monks were probably the first to use these new timekeeping machines to help tell the time for when prayers should happen. So they'd be connected to a bell, and at a certain point the bell would start to ring, and then the monks would know, okay, it's time for prayer, and they'd all gather in the chapel. So it's interesting that the monks are at the forefront of the science of time. Clocks then spread from monasteries to cathedrals into towns and secular life as well. And this is the point at which an hour became a fixed amount of time, because before this, an hour was a unit of time that was flexible. So you'd have 12 hours between light and darkness. And so in the summer, when you have more light, an hour is longer, because you divide that into 12. And in the winter, when you have less sunlight, the hour is shorter, because it's still divided into 12. So it's a flexible unit. But with the rise of mechanical clock, then an hour becomes a fixed unit. That's the basis for what we still have to this day. So, let's see. This slide shows a recent book from 2020 by Seb Falk at Cambridge University, and it has this intriguing title, The Light Ages. This is countering the myth of the Dark Ages that I have been talking about, as if there was nothing important happened for the history of science and medicine in the Middle Ages. Clearly, there were important things that happened, and so the surprising story of medieval science, and this book is called The Light Ages, showing a different way to think about the story, that's for sure. And so, significantly, the medieval period really laid the foundation for one of the greatest achievements of Western civilization, which is modern science, and hence modern biomedicine, which many of its principles are derived from the scientific progress that happened. So the medieval period is super important for our understanding and our next phase of our course, which is the scientific revolution. We have to understand that medieval background, because there really is a continuity. Not everything was new in the scientific revolution, as if they didn't know anything before. They knew a lot of things before. And in fact, Galileo himself, pictured here, his work, especially in the study of motion, was directly related to work that was done at Oxford in the 14th century by the Merton calculators, they were called. This was a group of scientists at Oxford who created the mean speed theorem, which states that a uniformly accelerated body starting from rest, in other words, zero initial velocity, travels the same distance as a body with uniform speed, whose speed is half the final velocity of the accelerated body. Now, that mean speed theorem was the basis for Galileo's own studies of motion, and there is evidence that he knew their work. So there's a continuity between these medieval studies of motion and the work of Galileo during the scientific revolution. Super fascinating. So, to sum up this medieval period, I think it's really important to mention also the universities. We'll say more about them in a little bit, but in the universities, this is where academic freedom thrived. And the legacy of Christian theology, which I've also mentioned, was uniquely suited to encourage the study of the natural world. So universities, Christian theology, and then lastly, the legacy of the Middle Ages was really faith in reason. That medieval Europeans cultivated a really profound faith that reason can know the world. Human beings can know truth. I mean, in some ways, they had more confidence in reason than we do in our own 21st century, in our relativism. And believe, oh, that's what you believe, and that's what I believe, and, it's all good. The medievals would have none of that. They would argue that we can know truth, not just about the physical world, but about the metaphysical world as well. Truths of ethics and theology and epistemology, how we come to know things through our senses, etc. They had great confidence in that. And that's the third element. Universities, theology, and then the confidence in reason that was sort of injected into the European mentality in the Middle Ages would form a firm foundation in the scientific revolution, as we'll see very soon. Now, one way I think to summarize this is James Hannam here, this historian of science who has written a very fascinating book on medieval science. He says this, that the most significant contribution of the natural philosophers of the Middle Ages was to make modern science even conceivable. They made science safe in a Christian context, showed how it could be useful, and constructed a worldview where it made sense. Right. Now, shift gears a little bit. In order to understand really the significance of the medieval period in the history of science, we're going to do a little contrast. I want to take a look at what happened to science in the Arabic world. This is an article in the New Atlantis by Hillel Ofek. It's quite fascinating. You can find it online. Why the Arabic world turned away from science. Now, you'll recall that there were great achievements in the Arabic world and in the medieval Islamic world in science and medicine. Great achievements from the 700s, 800s into the early 1200s. Islamic scientists advanced the fields of algebra, geometry, chemistry, biology, medicine, astronomy, and many of their great texts and preservation of the Greek texts as well were translated into Latin and studied by Europeans, much to their benefit. The Europeans looked up to the Islamic world for education in science. Isn't that interesting? It's so different than what we would think today. Because today, as in this article, the author here, Hillel Ofek, remarks, he says this, that today, 46 Muslim countries combined contribute just 1% of the world's scientific literature. Wow. So now, it's true that decline of scientific cultures is normal in history. You get ups and downs and things. Still, there's some interesting and important factors that historians have pointed to help us understand why these great achievements of the medieval Islamic world, why they disappeared, and why there wasn't that sort of continued commitment to science in the Islamic world for a long time into the modern world. And that'll give us some indication of perhaps why the scientific revolution happened then in the Western world, in Europe in particular. All right? So this is a fascinating story. So just hang on for the ride here and get good notes. So pause the video if needed. But let's get started understanding why the Arabic world turned away from science. So this is an image from al-Biruni of the 11th century, a great Islamic scientist, explaining the phases of the moon. Sophisticated, beautiful. Again, Europeans were looking up at this, and they were copying and translating much of this into their own world. However, by about the 1200s, there was a lessening of scientific activity happening. Sure, there were political and military reasons for that too. The Mongols were invading and destabilizing the Islamic world. But the problems started even before the Mongol invasions. So historians have pointed to a main problem that they see happening in the Middle Ages in the Islamic world. And that was that increasingly religion held kind of an unlimited sovereignty in the Islamic world, coming to dominate it by the late medieval period. One historian, Niall Ferguson, wrote this. He said, quote, "Toward the end of the 11th century, influential Muslim clerics began to argue that the study of Greek philosophy was incompatible with the teachings of the Quran." Unquote. Studying Greek philosophy, incompatible with the Quran. Now that's pretty interesting. That debate was also happening in Christian medieval Europe. There were some Christians who thought that, studying the Greeks wasn't a good idea, that it can, it could like dilute the faith, and that you really shouldn't study the Greeks. You should just, study the church fathers and the Bible. But most of the scholars in the West derided that idea, including great figures like Thomas Aquinas, who, as we know, was a deep student of Greek philosophy and science as well. And they believed that they could be reconciled, and that the Greeks had many true and beautiful things to say about the world, and that this was ultimately reconcilable with a Christian worldview. This was very different than what started to happen in the Islamic world at about the same time. Where in the Islamic world, many of these leading clerics began to argue that it was blasphemous to argue that humans could access the mind of God through reason. God is the cause of all things, they would say, which implicitly is a denial of the whole sphere of secondary causality. That is the basis for the study of nature in the Western world. Right? We've seen this with the Greeks, right? Go back to naturalism. The Greeks believed in the divine, but they didn't think the divine caused everything. Right? We made that distinction between the sort of the mixture, the mingling of the natural and the supernatural that we saw in the medical anthropology in many parts of the world, where the divine is sort of directly involved in diseases and healings and things. But the Greeks were different. They were starting to distinguish the two, yes? And the naturalism of the Greek world said, yes, here's the divine, but here's the sphere of nature that has its own causes within it, and we can understand those causes through reason. Well, this was highly compatible with a Christian worldview, all the way back to Genesis. God creates the world. Jesus is divine reason, and so therefore the human mind can correspond with the world and understand it. The whole sphere of secondary causality then is super important within the Western rise of science and biomedicine. But this sphere of secondary causality, belief in it at least, was declining in the Islamic world in the medieval period. So that there was ultimately a disconnect between the creator and the mind of the creature. It seemed to more and more scholars in the Islamic world that thinking that the human mind could somehow reach to God through reason was blasphemous, that somehow denigrated God, and we need to keep God really high and humans really low in order to understand the proper relationship there, right? That was very different than in the Christian world. There was also an increasing understanding that studying the Greeks leads one to lose one's Muslim faith. And so we start to see this kind of a juxtaposition of faith and reason, either or in some ways, either or. And so increasingly the madrasas, or the Islamic schools, focused on theology. And, there were other subjects too, to some degree, but increasingly the weight was put on theology. And this was happening at a time when the European universities were broadening to many subjects. So one historian, Toby Huff, in his 2003 book, Rise of Early Modern Science, Islam, China, and the West, wrote this, quote, "From a structural and legal point of view, the madrasa," that's the Islamic school. Actually, let me write that here on the screen. Okay. M-A-D-R-A-S-A, right? Madrasa, that's the Islamic school. He says, from a structural and legal point of view, the madrasa and the university were contrasting types. Whereas the madrasa was a pious endowment under the law of religious and charitable foundations, waqf it was called, the universities of Europe were legally autonomous corporate entities that had many legal rights and privileges. These included the capacity to make their own internal rules and regulations, the right to buy and sell property, to have legal representation in various forums, to make contracts, to sue, and be sued. So we're used to this kind of language, the language of rights and corporations in our own modern world. Well, it turns out that the basis for that was created in the medieval period, and universities really led the way. There were certain other institutions in the medieval period that did that too, but universities were certainly one of the more important ones, and that is the fundamental difference between the madrasa and the university. And so we can see then that this academic freedom, this sort of independence of these universities, allowed them to create scientific achievements and then pass them on to the next generation of students, and then build on that. You have brilliant scientific minds in the Islamic world, but the problem is you didn't have an institutionalization of free inquiry. And so their brilliant discoveries weren't necessarily passed on to the next generation of students. And so you don't get this sort of accumulation happening in the Western universities. It's really fascinating. So one of the problems in the Islamic world, and this slide is trying to illustrate here with Islamic calligraphy, which is extremely beautiful, an amazing work of art. This is on pink paper from the early 13th century. And so I'm showing this slide because one of the problems with calligraphy, as beautiful as it was that it acted actually as a roadblock to the acceptance of the printing press in the Islamic world, because this had to be, calligraphy is something that's done by hand, and the script was sacred, and there's sort of a reverence for calligraphy, especially when writing the Quran. And so this meant that the printing press, this sort of awkward mechanical kind of printing, was not only frowned upon, it was even banned from parts of the Islamic world. Sultan Salim I in 1515 threatened with death anybody found using the printing press. Yikes. So obviously, if you don't have a printing press, then you don't have rapid circulation of knowledge, which you get in Europe. That would play a really important role in the scientific revolution getting going. But keep in mind that the printing press was a late medieval invention, around 1460. They're spreading in Europe. And, by the 1600s, there's hundreds of thousands of texts are being, cranked out and spread around the continent of Europe. That's an important background, for sure, to the scientific revolution. Well, if printing is illegal in at least the Ottoman Empire here, then that is a pretty big damper. And it helps us to understand why the scientific revolution is happening in Europe and not there. So, let's see. Let me show you now this slide. So I want to dig into this question a little more deeply. So why did the Arabic world turn away from science is the question we're trying to ask. And the reason I'm asking it is because it's going to illuminate the importance of the medieval achievements further. So here's a little case study that I'm taking from the historian Niall Ferguson in his book, Civilization, the West and the Rest. And I want to contrast two observatories. This one is an Islamic observatory in Istanbul that was active between 1577 and 1580. And this has quite advanced tools and equipment you can see pictured here, quite similar to what was used in the West by scientists such as Tycho Brahe. So this is impressive. It was built by Taqi al-Din, who was a Muslim polymath, just brilliant mind. He was the author of more than 90 books on a wide variety of subjects, including astronomy, clocks, engineering, mathematics, mechanics, optics, and natural philosophy. Just an amazing guy. And in 1574, the Ottoman Sultan, or ruler, Murad III, invited Taqi al-Din to build this observatory in Istanbul. So, using his exceptional knowledge in the mechanical arts, Taqi al-Din constructed instruments like huge armillary, which is a model of objects in the sky, and mechanical clocks that he used in his observations of the Great Comet of 1577. Taqi al-Din's methods of finding coordinates of stars was reportedly more precise than those of his contemporaries in Europe, like Tycho Brahe and Nicholas Copernicus. Brahe is thought to even been aware of Taqi al-Din's work, right? So at this point in history, you have a rough parity or a rough equality between some of the astronomy work being done in the Islamic world and in Europe. However, notice the short time span, 1577 to 1580. And here is how this kind of overpowering role of religion in the Islamic world worked. That's part of the argument here. So Taqi al-Din, who built this observatory, was accused by a Muslim cleric of astrology. So the Sultan was convinced by the religious leaders to demolish the observatory in 1580, and there was not another observatory in the city of Istanbul until 1868, hundreds of years later. So this close interweaving of religion and politics and Islam was from the beginning. And legally autonomous institutions were absent from the Islamic world really until the 19th century, according to OFEC. So this means that, if this observatory had been connected to a university, right, then this would have been an independent thing, and the Sultan couldn't just come in and, we're going to shut this down. But because it's sort of a top-down, and the religion and politics are really closely interwoven here, the Sultan was convinced by the religious leaders that this was a dangerous thing for the faith, therefore, close it down, 3 years, and it's gone. Now, contrast the story that I've just told of the Istanbul Observatory with this, the Vatican Observatory. So this was built at the same time, 1578 to 1580. Built at just about exactly the same time as the observatory in Istanbul. And it's definitely one of the oldest observatories still in operation, although it's not the main Vatican Observatory anymore. But it's definitely one of the oldest astronomical research institutions in the world. Built in this Gregorian tower here, which you can see in the foreground, and you can see the dome of St. Peter's in the background. So this is in Vatican City. And it was built in preparation for the very sophisticated scientific work that had to be done to create the Gregorian calendar in 1582. Now, the Gregorian calendar is still used today as the basis for our year and our week and everything. Easter and Christmas, and it's still, which is still the most widely used civil calendar in the world, the Gregorian calendar, and that was something created in 1582. So pretty fascinating. Instigated by Pope Gregory XIII. Although, interestingly, Protestant and Orthodox countries refused to use it for a long time because it was instigated by a pope. And so they retained the older calendar, which wasn't as accurate, and it took them a long time before they grudgingly dragged their feet and finally adopted the Catholic calendar. Britain didn't even adopt it until 1752. So, anyway, kind of humorous. But this is a picture then of the Vatican Observatory today, which is now in Arizona, interestingly, because of very clear skies and a kind of safe and stable environment. So, pretty fascinating. Now, this is an image of a mosque slash madrasa, the school again, of Sultan Hassan in Cairo, built in the second half of the 1300s. So this is a medieval mosque and school in the Islamic world. You can see the modern city in the background there. But I'm showing it to emphasize this close link between religion and politics in much of the Islamic world, and really all the way back to Muhammad himself, who was both a religious prophet but also a political leader, very much unlike Jesus in that sense. And so this is a symbol of how clerical power worked in the Islamic world, and a cultural problem in which there was a failure to create institutions where science could carry on freely. The Islamic law did not recognize any corporate groups as having sort of an independent legal identity, apart from the state. This was true in China as well, which was dependent on the official bureaucracy of the state. So this meant that, as I mentioned before, intellectual discoveries in the Islamic world here could not very easily be carried on by students in this freedom of inquiry, which ultimately was grounded in a failure to recognize faith and reason. We saw that problem all the way back into the Central Middle Ages, as more and more in the Islamic world were sort of separating faith and reason from each other. So the argument here is this, that the Western world, the Western civilization, began to really pull ahead of the Islamic world, and particularly the Ottoman Empire, scientifically, because of a theologically favorable environment that allowed for the institutionalization of free inquiry, necessary for the scientific revolution and, later on, the Age of Enlightenment. That Christian theology, grounded in the goodness of creation, the infusion of reason in creation, and also the freedom of the human person, that those three principles within Christian theology provided a safe space, so to speak, for the emergence of modern science in the scientific revolution. Now, one last important point to make here in sort of contrasting these two parts of the worlds, medieval Europe with the Islamic world, was that, within the medieval world, there was a lot of experimentation going on, especially with gunpowder and various military technology. And you have all these different kingdoms in Europe that are constantly fighting each other, which was a big problem. It made a messes constantly, lots of violence and things. But I guess one of the outcomes of that was advancements in military science. So the application of scientific knowledge to military power, the West dominated in this for sure. Competition, innovation, and this kind of military science really began to open up a huge gap between Western civilization and the Ottoman Empire, but in reality the rest of the world, for sure. So, other places had guns, but the Europeans really improved those guns. And this is seen in a text like this, an important text, New Principles of Gunnery, the determination of the force of gunpowder, and an investigation of the difference in the resisting power of the air to swift and slow motions by Benjamin Robbins, published in London in 1742. Now, this book, very fascinating, applied Newtonian physics to the problems of gunnery. It was quickly translated into other languages, and you could calculate accurately altitude and range. And this gave an edge to Western artillery that nearby non-Western powers like the Ottoman Empire just could not compete with this. Couldn't compete. So now this book has 2 chapters in which he set out a series of propositions which form a model for the physics of guns. You can see a diagram here of the interior ballistics of a cannon, for example. So Robbins then goes on to report the results of testing the model's predictions against experiment. And so this is just a beautiful example of the scientific method at work. So by the early 1700s then, the Ottomans, who were still, leaders within the Islamic world, but they knew that by the early 1700s they had to begin to learn from the West. They began to study the West. Ibrahim Mutafarrika's 1732 book was called Rational Basis for the Politics of Nations. He asked this question, quote, "Why do Christian nations, which were so weak in the past, compared with Muslim nations, begin to dominate so many lands in modern times and even defeat the once victorious Ottoman armies?" That's the question he asked in that book from 1732. Because Ottomans were realizing they needed to adopt the scientific revolution and even certain achievements of the Age of Enlightenment if they were going to compete. But problem is, they were so far behind, so far. Mutafarrika, for example, introduced the first printing press into the Ottoman Empire in 1727. So that's, 250 years after it had been created in the Western world and spread all around. So this, in conclusion then, just emphasizes this significant basis for modern science that the medieval period, in Europe in particular, created.